Good morning, all. We are on page 123 today. We are in lesson 12, module 2, and our lesson today is all about estimating digits in a quotient. Now, if everybody can think back with me, quotient. Can we think of what a quotient is? You should have it written in the front of your book, but in case we don't, we're going to write it here at the top. Whenever they're asking for a quotient, this is going to be our answer to what type of problem? It's going to be division. Okay, so quotient is always going to be our answer to division. Let's review again. Our sum is for adding. Our difference is for subtraction. Our product is for multiplication. And then here we are, our quotient is for division. Okay. Today is all about estimating and rounding and that mental math that goes along with it. Please, just a precursor, don't get frustrated with this. This is all about rounding. I know you guys did a little bit with rounding last year. Now we're just expanding on this a little bit. Honestly, we're looking at big numbers, very big numbers, and we're rounding to make it easy mental math for us, okay? So that's what this is all about, is that mental math and being able to do it in our heads. But then take our calculator and look at our calculator and see if our answer is indeed close, not close. Would estimation work in this situation or would it not? Okay. So normally this would be a discussion in class, but here we go. So divide 150 by 300. Now, if we're writing this, we have our word problem there, divide 150 by 30. How would we represent this in a division problem? So we're going to divide, we know this, we're going to use our division symbol, right? So we have 150 divided by 30, okay? Now, can we write this in a different way? So as I'm thinking like our fractions, okay? So remember we would have like 15 tenths and 3 tenths, okay? We don't have fractions here, but we do definitely have place values here. So if we look at this, we have 3 tenths and 15 tenths. So we can't always write it as 15 tenths divided by 3 tenths. Okay, that would be our next one. So if we remember, do we remember with fractions when we had like 15 tenths divided by 3 tenths? Then we would cancel out our tenths. We just cross those out and be 15 divided by 3. Right? Everyone with me? Remember this? I hope. So if we're looking at this and we have 15 divided by 30, here's what we know. We can do it a couple different ways. You can do your partial product, okay? You can do 150, then divide it by 10, which will give you 15, and then divide by 3, okay? So 150 divided by 10 is 15. We cancel our zeros there. And then we have 15 becomes 15 divided by 3. 15 divided by 3 is, I hope everybody remembers, that's 5, right? Awesome. Another way we can take this is we can cross out our tens, right? And so essentially it becomes 15 divided by 3, okay? I'm going to draw some lines here so we can see a little bit of division here. The other way to look at this is 150 divided by 30. Okay, we cross out our zeros. 3, and then we have 5. Okay. And then our last one, guys, we can always just do the standard algorithm, right? We all know this. I mean, looking at this, 3 times what equals 15? You know, because you could essentially put an X here. So 3 times blank equals 15 if you think about it. And we've checked ourselves, so we know 150. Okay, so this is our standard algorithm. This we're using place values. You're dividing power of 10 here, and here we're doing partial quotients. Okay, so go ahead and copy this. I'd like you guys to set it up the same way that I did, please. And also don't forget that quotient up there at the top. Remember, our quotient is always our answer to a division problem. Okay. Okay. Now, number 1, round to estimate the quotient. Okay, estimate. No, guys, this does not mean we are getting an actual answer, right? No. This just means that we are estimating. Okay, we are estimating. We are guessing. It's an educated guess. Okay, so please don't get hung up on the actual exact answer. We will do that with a calculator. See, use a calculator. Okay, and we're going to compare the two. So if we look at our directions here is around to a 1-digit arithmetic fact. Arithmetic is a number, okay? 1-digit number, okay? Estimate the quotient. So if we have 2,970, that's our first one, right? 2970. We're dividing that. Let's look at 11. What is 11 closest to? The whole number it's closest to. I would go by tens if I was doing this because we're dealing only with 2 digits here. We're dealing with our tens, right? So 11 goes down, right? If we were 15, it would go up to 20, but we're at 11, so we're going to go down to 10, okay? Now, guys, they want 1 digit, right? What do you think? 297 divided by 1. We crossed off our zeros there at the end, okay? So we know that this equals, we're dividing by 1, so anything divided by 1 is itself, right? Okay, so now they want us to get a calculator out. So we're going to get a calculator, and we're actually going to do 2970 divided by 11, the big number, right? 2970 divided by 11. Were we close in the grand scheme of things? Yeah, not too bad. If we're dealing with money, estimation doesn't really work because I'd rather have $297 than $270, honestly. But this gets us in the roundabout area. So if you're in construction and you need to build a fence, you have 2,970 feet, and each one is 11 feet long. So if I look, each one's 11 square feet, right? So if I look at this and I just simplify and estimate, I'm going to need 207. I buy 297 boards. I'll have plenty of boards to finish my job without having to go back to Home Depot to get more. Okay, that's one of the benefits of estimation is you will have, if you go down, you will always have more. Okay, obviously if we round up, we will have less. But in this instance, we will have plenty of boards to do my 270 boards instead of, because I'm going to buy 297. Okay, that's kind of a real world application. Go ahead and pause and copy, and then we're going to flip the page. We're going to do a few more. Okay, so this one here, we have at the top of page 124, we have 4,752 divided by 12. They want us to once again round to 1 digit, right? 1 digit. Okay, So here we go. If we do it a couple different ways. So they want us to round both. Okay, so they want us to round our 4,752, and they want us to round our 12. Okay, so we have 40. Let's just line them up. Okay, this one digit, meaning there will be something here, nothing here. These will be zeros. So if I put zeros here, would this go up to 5,000 or down to 4,000? It will go up because you're over 5. Okay, it's going to go up. Okay, and here I have 12, and I'm going to one digit. So I have a 0 here. They want one digit. So we're just making sure that we have one digit here and the rest is zeros. Okay, 2, does that go up to 20 or down to 10? It's less than 5, so it's going to go down. Okay, so then we have 10,000, or 10 divided by 5,000, right? Or 5,000 divided by 10, sorry. So essentially, if we can look at it lots of different ways, okay? So if we reduce this down, we go to 500 divided by 1, which equals 500, right? So that would be my estimation, would be 500, right? Okay. Now they want us to actually get the quotient to see how close we are, okay? So if we have 4,752, yes, I always rewrite the problem so I know what to put into my calculator. Divided by 12, yes, I know it's right above there, but we always need to write down our rewrite our problems, okay? So 4,752 divided by 12, I'm doing this on my calculator, by the way, is 396. What do we think of estimation in this point? That's a big difference. 104 is a huge difference. If we think about that, that's going to be like 20% difference, okay? So this, in this particular instance, this is a big difference, okay? If you're estimating as if you're doing for like catering, okay, so I have this many people coming and each lasagna feeds 12 people, so I need 396 lasagnas, right? So if I'm estimating, this would say I need 500 lasagnas for my big old festival. Yes, I would rather have 500 lasagnas, but I would hate to have 104 lasagnas left over in the same instance. So it can help with cases of catering, or even, like I said before, construction, okay? Estimation, there you go. Okay, so the next one, 11,647 divided by 19. We are going to round to one digit again, okay? So we're estimating the quotient, and then we're going to use our calculator to find the actual quotient. So we have 11,647 divided by 19. So 11,000, guys, we need to go to, they want us to go to one digit. I personally would take 11 here, and I would take the 1 here. So this is going to be a 0 here, and then we have 3 zeros here. So 11,000, is that closer to 10,000 or 20,000? What do you think? What do you think? 11 to me is closer to 10, so this is going to be 10 here. We could even, if we're going by thousands, I would even, if we take the 640, let's do it a different way. Let's take the 647, okay? We're going to take the 647 and we're going to round it to the nearest thousand. Okay, so 11,647. Is it closer to 12,000 or is it closer to 11,000? I would say this is closer to 12,000. Okay, so then here, 19. So this is going to go up. Is this closer to 20 or 10? Because we're going one digit here. I would say 20, personally. Okay, so we have 12,000 divided by 20, right? Okay, perfect. So if we take our zeros, let's do our zeros. We take 1 0 off and 1 0 off here. So we have 1,200 divided by 2. 12 divided by 2? Anybody? That's 6, right? And then we have 2 zeros left, right? So our 2 zeros go right there. Okay, so 600 times. So we would say this equals 600. Okay. Yeah, some of you can probably do it in your head, and that's awesome, but we can do this too. Okay. It's an estimation. We want to be able to do it in our head, okay? Do the mental math. And this kind of breaks it down for us so we can do the mental math without pulling out a calculator, okay? Now the bottom. 11,647 divided by 19. Remember, always rewrite your problems so you know that you have the right numbers, okay? 11,647 divided by 19 is equal to 613. That's pretty decent. Wow. That's pretty decent. There's only a difference of 13 here. What do we think? This one's a little bit better. When the numbers are a little bit closer, the estimation, it does show up and they're very close. When they're further away, it does make it a little bit more difficult, guys. I get that. Okay, let's do number 4. Okay, so pause if you need to and copy. Okay, so number 4. Let's look at this one. Okay, so 40,644 divided by 18. Sorry, 18. So this one I am going to rewrite it 4644 so I can have my right next to each other. Okay, so this one digit. So we're gonna do this one and this one. Okay, we have a 0 here. 0 0 0. 40 or 41. You could do 41. I would almost do 40 at this point to make it a good estimation. Because if you go to 41, because over here 18 is close to 20, closest to 20. So if you go to 41, you're going to end up with kind of an oddball answer. So I would leave it at 40. Guys, this is your choice. It is not my choice. It is your choice. So if you want to go 41, you go with it. You're the one doing the estimating, okay? We're going up on this one, okay? So if we go over here, 40,000 divided by 20, we cross out our zeros, right? 4 divided by 2, we know that is 2, right? We can rewrite it. 4,000 divided by 2. We know, guys, can we split 4,000 in half? Yeah, we can. We can split it in half, right? Yeah. So our answer, 20,000. And if you think about it, we could do this in our head. 40,000 divided in half, I mean, is 20,000 or 2,000. 2,000. Sorry, I put an extra 0 on there. It's 2,000. Goodness gracious. Look at me. Okay. Now let's see what it actually is. Let's see what our actual answer is. So 4644 divided by 18. Okay. 4644 divided by 18. I hope you guys all have your calculators out. 2258. Not bad. In the grand scheme of things, not too shabby. Okay? Not too shabby. Okay. What do we think? I mean, 258 is a big difference. It is, you know, you're dealing with a little bit bigger numbers, so you are going to have a little bit bigger difference if you think about it. Okay, so let's look at number 5. Okay, 49,170 divided by 15. Okay, 49170 divided by 15. Okay, this one is going to go, I would say, to 20. If it were me, I would go up because it's 15, right? This is 49. I would go up to 50. Yeah, personally, if it were me. So guys, I mean, we can do this in our head. 50,000 divided in half, or 5,000 divided in half, technically, right? Be 2,500, right? So if you think about it, like 50 divided in half here, you can really just simple it down to 50 divided by 2, 20 divided by 2. Okay, 25. Add your 2 zeros. So we have 50, 1, 2, 3 divided by 20. Cross out your zeros there, so you have 1, 2, 3 divided by 2, 2,500, right? We good? So now we need to check and see how close they are together, okay? Remember, this is the bigger numbers, guys. So the estimation is going to help, but it's not going to be an exact science at this point. 49,170 divided by 15. So 3,278. That's too far away for me. 5 here, this jump to 5 is too far. And it would be the same way as if you went down to 10, okay? It would actually probably be worse because you would be up at 5,000. So if you made this a 10, you would be up at 5,000. So, estimation, okay? Okay. So, this last one, 918 divided by 27, okay? We can look at this, estimate and apply the division algorithm to evaluate the expression, okay? So, first they want us to estimate, and then they want us to use the, oh, sorry, you guys can't see, I'm so sorry. Example 3, extended estimation in place value, okay? So, page 126. They want us to look at this one, and they want us to try and estimate it, and then they want us to look at it and do the standard algorithm, okay? So, we have 918 divided by 27, okay? So we're going this digit here and this digit here, right? So this is 18, so I would go down to 900. And this is 27, so I would go up to 30, okay? Because we have zeros, right? So we know that, 3 and 9 is 3, right? So you can cross out your zeros there. 3 goes into 90 30 times, right? Now they want us to do the algorithm, the standard algorithm. You guys ready? Let's do this. So we have 27. Ooh, where did I get 30 from? I had 30 from there. I am so sorry. Here we go. Try this again. So we have 918 divided by 27, okay? So we know from our estimation, guys, it'll go in about 3 times is what I would say. Because it's under 30, it will definitely go in 3 times. Okay, so 3 times 7 is 21, right? Okay, 3 times 2 is 6 plus our 2 from over here. Remember, 21, carry our 2. So that would be 8. So we have 10 left, right? And an 8. right? Bring down your 8. I taught this last year in Miss Maurice's class. Okay, so 18 can't go, can it? I don't think so. Can it? Right? Today? Oh, I did this wrong. It's 108. Oh gosh, guys. There we go. It's 108. 1 minus 1 is 0. 9 minus 1 is 1. Or 9 minus 8 is 1. 108. Okay. So how many times? So we know it goes in 3 times at 81. I believe I can add another one. So let's just try it with 4. Okay. I have white out. So 4 times 7 is, I believe, 28, right? Carrying my 2, 4 times 2 is 8, plus 2 is 10. No way. I didn't even look at the book. There we go, 108. Okay. So 30 to 34, not too bad, but it's because you went down here. Okay, that 18. But comparing the two, 30 to 34, that's not a huge difference. The estimation is pretty decent at that point. But do you see how estimation can help you with their standard algorithm? Because I don't know what 27 times, I don't know how many times 27 goes into 91. The estimation helps you know that it'll go in at least 3 times. And that gives you kind of that jumping starting point. So this can, when you're doing the standard algorithm, this can, estimation can really help you. Okay. Okay. So, that's it for math today. Oh, sorry, pause if you need to copy. Okay. Okay. Exit ticket, yes, you will do. Round to estimate the quotient, then compute the quotient using a calculator. Compare the estimation to the quotient. So compare the two. Tell me your thoughts. Way too close, way too far away. I don't trust this estimation, whatever. Put it in your own words, okay? Yes, I will need to see the breakdown just like these, like number 2, okay? So show me, you know, how you went up or down, why you picked those, so I can see why you picked those numbers, and then I want to see the actual out here, okay? No, I'm not asking you to do the standard algorithm. I'm not going to torture you that way, but you are going to do your exit ticket and turn it in. If you have any questions, I will be available at 9:30. Okay, bye guys.